Hey everybody, this is Mr. Piercy, and what we're going to be looking at today in this video is properties of corresponding arcs when we have congruent chords inside of a circle. For the demonstration, if you're going to be following along to try and do it yourself, I'm going to use a straight edge, a compass, a pencil obviously, and I'm going to use a couple of different colors to help, you know, keep things a little bit distinct. Sometimes when you're doing constructions like this, if you do everything in a pencil, things blur together and it can make things difficult to see. I'm also going to use a sheet of patty paper to help me compare some things in my figure, although it's not necessary. You can use the actual measurements of the protractor to do that as well. So to start off, what we're going to do is start with making a circle. I don't want to make it very small, but I don't want to make it very large either. Something big enough that we can see things clearly on our paper, okay, and still be able to make some constructions on it. So I'm going to call this circle A. Now what I'm going to do is I'm going to construct a pair of congruent chords inside of the circle. So I will make a chord from here and I will make a chord from here. So I will call this L and M. Now to make the congruent chords, I'm going to just open up my compass to be some kind of arbitrary length. Again, I'm not measuring it at all. I'm going to just say, okay, well, let's make something like that, and without adjusting the compass, I'll come here at point L and make another arc that intersects the circle somewhere. And we'll label those, and we can call this N and P, these points here. Now taking my straight edge, what we have is we've constructed two chords inside of the circle. So we've constructed Ln to be congruent to MP. So if we were doing this as a proof, maybe that might be information that's given to you. And just to double check, we can use the protractor here. We haven't adjusted anything. I'm sorry, the compass. We can see that's however long that is at segment MP, and we can see that Ln is the same length. Now this is what I'm going to use the colored pencils for. From point A, I am going to draw in the central angles of both of the chords. So we have central angle MAP, and I'll do the other one in a different color here, and this will give me LAN, central angle. And there we go. So we have two angles here. So I have angle MAP and LAN. Now this is where I'm going to use my patty paper. All I'm going to do is I'm going to copy one of the angles. It doesn't make a difference which one. I'm copying the one on the right just because I'm right-handed. It's easier for me to do than the one that would be on the left. So here I've copied angle MAP. Now what I'm trying to do is I want to compare, is angle MAP the same or different than angle LAN? So I'm going to take my patty paper and I'm going to just reflect it, turn it over, and lay it on top of the other angle. And we can see that the two angles are congruent to each other. So here I can say now that angle MAP is congruent to angle LAN angle. And one of the things that we have seen in previous lessons is the measure of an intercepted arc of a central angle is congruent to, or has the same measure as, the central angle. So whatever measurement, however many degrees uh, angle MAP happens to be, we would have the same measurement in degrees as arc MP. So I can say, and I should say the measurement here and the measurement here. So the measurement of, well, I don't really know the measurement, so we're not going to say the measurement. But now I can conclude that arc MP must be congruent to arc LN. So what that allows me to conclude is intercepted arcs, I can't spell, of congruent chords are themselves congruent. And so the converse of that would also be true. If I know I have two congruent chords inside of a circle, then, or I'm sorry, if I know I have two congruent arcs of a circle, then the chords that would connect the endpoints of those arcs would have to be congruent to each other. So that is what we're looking at here. This is one of the properties of chords inside of the circle. So if I have congruent chords inside of a circle, then their intercepted arcs would be congruent to each other. And conversely, if I have two arcs that are congruent of a circle, then their respective chords would be congruent. But that's all we're looking at in this particular video. Be sure to keep in touch and follow me, and you'll be seeing some more circle videos here shortly. But until next time, guys,